Welcome everyone. Today we'll be discussing a very important topic in your chemistry, and this topic is very essential whether you're preparing for your JAMB UTME, for your post UTME, for your WAEC, or even for your class exams. And this topic is not what the type of what reaction. We cannot talk about chemistry without talking about what the formation of what substances. And when we talk about formation, and that is what we call in chemistry as well, that is what is known in chemistry as what reaction. So what is chemical what reaction? So we say our chemical reaction, are changes. We say chemical reaction are changes in which some new chemical substances, in which some new chemical substances, are what formed. In which some new chemical substances are what formed. So we say chemical reaction are changes in which some new chemical substances are what formed. But before we continue, my name is Basi Ejogba. I'm a student in the University of Calabar studying medical laboratory science. And in my channel, I help students develop their academic game. I also share food tips on the channel, focusing on personal development. So if you love content like this, please don't forget to hit on the red subscribe button so I can continue getting updates anytime I drop videos like this, and so that you can help me grow. And just like I said, we are going to be talking about what the types of what reaction, and which we have already given the definition of what a reaction is all about. It says chemical reaction are changes in which some new chemical substances are formed. Now, the substances that undergo this reaction, are known as the what reactants, right? So substances that undergo this reaction are known as what the reactants. So we say our reactants plus what our reactants will give us the word new word chemical substances which are being formed, and those new chemical substances that are being formed are known as what the products, right? So that is just it. So we say our reactants will give us what our what product, right? So these are the what are the substances starting the reaction, and this is the word like the end word process, or the word the end word results, right? So we are going to be talking about the types of what this word reaction. So when it comes to what chemical reaction, we have a lot of what chemical what reaction. We are going to be taking them one by one. So we'll be starting with the basic one, which is known as what the combination what reaction. We are going to be starting with the basic one, number one, which is what the combination reaction. The combination reaction. So for the combination reaction, according to the name, it's simply talking about what combination. So let me give you a concise definition. It says combination reaction is when two substances combine together to form what a single word compound. So when two substances combine together, two substances combine together to form what a new word compound. Right? So that is what combination word reaction. So this is simply saying an element plus what an element giving us what our word compound. Right? We say our element plus what element, which will give us what is known as what our word compound. Right? That is what is known as what a combination word reaction. Right? So let's simply use, for example, we have our hydrogen, right? We have our hydrogen, or even we have our any element, right? We say even our sodium plus our chlorine, right? Giving us our sodium chloride, for example. So we say the sodium is what an element, which is what a reactant, plus the chlorine, which is an element, which is a reactant, giving us our sodium chloride, which is what a compound, and which is the word product, right? So that is what a combination reaction is all about. It's simply what the combination when two substances come together to form what a new compound, mostly what element plus what element, giving us what a compound. Please take note that many organic compounds undergo what combination word reaction. Take note, many organic compounds undergo what combination word reaction. An example is the polymerization of what 18. Please take note, organic compounds undergo what combination word reaction. So the second one is what is known as what the decomposition word reaction. So we have the word decomposition reaction. So number two, we say the decomposition reaction. So the number two, we say what the decomposition reaction. So for the decomposition reaction, according to the name, when we say something is decomposing, so when we say something is decomposing, it means it's something is what being broken what down, right? It's being broken down, and this is the direct opposite of the word combination what reaction. This is the direct opposite of the combination what reaction. So we say the decomposition reaction. This involves the splitting of what compound into what more simpler what substances. Say this involves the splitting. This involves the splitting of compound. The splitting of what compounds. This involves the splitting of what compounds into what simpler what substances. Into simpler what substances. Remember, we did our combination reaction as number one, and we say our combination reaction is the what simpler substances coming together to give us a complex substance, which is our compound. But this one now is the what direct what opposite. So for this now, what will be having? Remember the first time we said sodium plus chlorine, that is our element plus element, giving us what a compound. But now at this particular point in time, what we'll be having is a compound which will be broken down to give us what element plus what an element. So we say element plus what element, right? So that is basically how it is. So let's say our sodium chloride, which will be broken down to give us our sodium plus our what chlorine, right? So this is our sodium chloride, which is our table salt, normal salt, Dangote salt, being broken down to give us our sodium and our what chlorine. This type of reaction is what is known as the what decomposition what reaction. And decomposition reaction takes place always in the presence of what heat. There must always be a presence of what heat. That is what is known as what the what decomposition what reaction. And when there's a presence of heat, such a type of decomposition is known as what the thermal what decomposition, which brings about the presence of what heat. Please take note, the type of decomposition reaction that brings about the presence of heat is known as what the thermal what decomposition, right? So we'll be moving on to the third type of what chemical what reaction, which is known as what the displacement what reaction. So the number 3 is what the displacement what reaction. So we have our number 3, which is our what displacement what reaction. So for the displacement reaction, this involves what one element or radical replacing what another element or radical in a what compound. So we say displacement what reaction. So we say displacement what reaction. So this is simply the short form of what writing what reaction, right? So we say for the displacement what reaction, one element displaces or replaces what another what element in a what compound. One element displaces another element in a what another element displaces another element in what a compound, in a what compound, right? So let's say, okay, let's see how it is. So this is represented by saying a plus what b what y, right? A plus what b y. In this particular point in time, what we'll be having as our forward reaction is going to be what ay plus what b. If we get to find out that there's what a displacement where this element has been able to what displace what this element out of this what you understand, this element has been able to display this element in a what compound, right? This is a compound because this is a b, this is a what a y, and this particular element has been able to display this b out of this what compound, making it taking the place of this what b, right? So you get to see ay plus what b. Let's take it down so that you'll be able to understand it. So let's give example using what our what element. So what we have here is our what zinc, right? We have our zinc and our what copper what sulfate, right? We have our zinc and our copper sulfate. So we say our zinc, which is what solid, right, plus our copper what sulfate. We have our zinc and our copper what sulfate. Our copper sulfate is aqueous, right? We have our zinc and our copper what surface, giving us what a forward reaction. So the moment you see this, you get to find out that what we'll be having is our what zinc what sulfate and our what copper what solution, right? We'll be having our zinc sulfate and our copper what solution, because the zinc here is going to displace this what copper. So we are going to be having our what zinc what sulfate plus our what copper, right? So we are going to be having our what zinc plus our what copper. So that is basically how it is, or how it works when it comes to what displacement. We are together, but I'm going to what remove what this particular element that is in what a compound, and I'm going to take the place of that what element in that particular what compound, and you get to find out that zinc has done it to what copper, removing copper from this what solution, from this compound, and it taking the what place of this what copper. So that is just how it is when it comes to the what the displacement what reaction. So also the next one we have here, take note, the displacement reaction is based on what electrochemical what series. So this is based on what, this is based on the what electrochemical what series, right? This is based on the what electrochemical what series. So displacement reaction is based on what electrochemical what series. It is very important you take note of the salient points that I am listing out in these videos. They are very what important. We have the next type of reaction, which is known as what the double what decomposition. That is our number 4. We have our what double what decomposition, right? Yes, we have our double decomposition. Right, from the name double, you are going to find out that double decomposition, the reactant decompose to form new substances by an exchange of what radicals. So we say number 4, which is our double what decomposition, right? We have our double decomposition, which says there's what an exchange of what radicals, exchange of what radicals, exchange of radicals, exchange of radicals, which give rise, which gives rise, which gives rise, which gives rise to new substances. Exchange of radicals, which give rise to what new what substances. That is what is known as what the double what decomposition. So we have our representation here is saying what AB plus what our what CD, right? Our AB plus CD is going to give us what AC plus what BD, right? So you get to find out this a double decomposition. So this is going to come here and this is going to come here. So you have our what AC plus our what BD. You get to find out that there's a decomposition, exchange of radicals. They are giving what they are. This one is exchanging with this one is exchanging with this one to what give us what our new what substances. So that is just how it is when it comes to the what the double what decomposition, right? So that is just how it is, right? So with this now, I'm not just here to dig deep, but I'm rather here to give you selling point which is useful if you are preparing for your WAEC exam, if you are preparing for your post-UTME, and you are preparing for your what JAMB what UTME. We are hitting the nail directly on the what head, right? So we move on to the next type of what reaction, which is known as the what the catalytic what reaction, and that is our number what 5. So our number 5, we have our what catalytic what reaction, right? Our 5, we have our catalytic or reaction. So when we talk about catalytic reaction, this involves what the presence of what a catalyst, right? This simply involves what a catalyst, right? Now what is what a catalyst? That is the first question you are supposed to ask yourself. What is what a catalyst? You say a catalyst is a substance which remains, take note, I'm reading it from my summary note. It says a catalyst is what a substance which remains chemically and quantitatively what unchanged at the end of what a reaction. A catalyst remains what chemically and quantitatively what unchanged at the end of what a reaction. Such a substance will remain what unchanged at the end of a reaction is known as what a catalyst. But now there's something a catalyst does. A catalyst alters the rate of what a reaction. A catalyst alters the rate of what a reaction. A catalyst tend to alter. It can either inhibit or it can either what promote the rate of what a reaction. That means a catalyst can fasten the rate of what a reaction. It is very important that as students we are able to differentiate what a catalyst is and what an enzyme is, because I used to see a lot of people get confused about what an enzyme is and what a catalyst is. An enzyme is simply what a biological what catalyst. Take note, enzyme is what a biological what catalyst. That is the only thing you're supposed to know when it comes to what an enzyme is. A what a biological what or organic what catalyst that is produced by what living what cells. So we say enzymes is a what a biological or what organic catalyst which is produced by what living what cells, right? That is what you're supposed to know about what a catalytic what reaction. And you're also supposed to know the characteristics of what a catalyst, right? You're supposed to know that a catalyst means the same at the end of what a reaction, right? It alters the rate of what a chemical what reaction. A catalyst is also what very specific in action. A catalyst cannot start a reaction. Please take note, a catalyst cannot start a what reaction. Also know that a catalyst has no effect on the equilibrium of what a reversible what reaction. And also note that the effect of a solid catalyst is improved. Take note of this selling point. It says the effect of a solid catalyst is improved by increasing its what surface what area. Right? It is very important you understand the characteristics of what a catalyst. And if you need a comprehensive and a concise note, if you need this note, this summary, feel free to chat me up on WhatsApp. Check the description, you get to see my WhatsApp number. Chat me up and I will send it to you. Right? So that is just how it is. Right? So let's move on also to the next point here, which is the next type of chemical reaction, which is known as what the reversible what reactions. So we have the number 6, which is the what reversible. We have the reversible and the irreversible. So I'm going to take them together. We have the reversible and the what irreversible what reversible and irreversible what reaction. So for the reversible and irreversible what reaction, these are reactions. For the reversible reactions, these are reactions in which the direction of the chemical what reaction can be what reversed. The reaction of the direction of the chemical change can be what reversed, while there are some that cannot be what reversed. And that is when you start seeing stuffs like this, right? Start seeing stuffs like this. Remember when I talked about the chemical change and the physical what change? One can be reversed and the other one cannot be what reversed. So it's very important you understand this key concept. So for the reversible, we can say the reversible can be the physical will change, and the irreversible is the what chemical will change. It's very important that you understand this word key concept. And we also going to talk about the next chemical reaction there, which is known as what the oxidation and the what reduction. So I'm just going to give you the key point of what the oxidation and the reduction is all about, and we are also going to see how we can be able to solve for what oxidation what number. So I'm just going to give you one example, and we are going to see how we can solve for what oxidation what number. So when we talk about the oxidation and the reduction what reaction, so we say number is a number. We say what the oxidation, right? We say oxidation. We have the oxidation and what reduction, right? We have the oxidation and we have the what reduction. So we have the oxidation and the reaction is that this particular type of reaction has what a lot of what definitions, but the one that we are focusing on right now, this our time, is what based on the what electron what transfer, right? Based on the what electron what transfer. But to make it very simplified, we can say oxidation is what the addition of what oxygen, and reduction can be seen as the what removal of what oxygen. Oxidation can be seen as a what addition of what oxygen, and what reduction can be seen as a removal of what oxygen, right? It is very important you understand this. But I said, based on what we are focusing on right now, oxidation and reduction is based on the transfer of what electrons. So based on the transfer of electrons, oxidation is a process involving a loss of what electrons, while reduction is a process involving what a gain of what electrons, right? So oxidation involves loss of electrons, while reduction involves what a gain of what electrons, right? Understand this key concept. We also say that oxidizing agent accepts what electrons, while reducing agent donate what electrons. Please take note of this and don't be confused. I feel like writing it down here. We said oxidation, right? Oxidation, right? Equals to what? Loss of what electrons. So oxidation is what the loss of what electrons, and we say what reduction is the what gain of what electrons. We say reduction is the what the gain of what electrons. Please take note of this, right? And we say oxidizing agent accept what electrons, and reducing agent donates what? Electrons, right? So that is basically everything you're supposed to know when it comes to this type of what? Reaction. JAMB will not ask you in depth. What JAMB be focusing on is based on whether you truly understand this what concept, right? And like I say, for every topic we are done with, I will see how we will surely solve past questions based on that topic. So if you need clarifications more on it, just make sure you subscribe so that when I will start dropping these past questions based on topic by topic, you will not be left out, right? So let's get one particular solving here. The solving we have here is find the oxidation number of manganese atom in potassium tetraoxo manganate 7, right? It says find the oxidation number of manganese atom. It says example 1, you say example, right? It says find the oxidation number, of manganese, find the oxidation number of manganese atom or manganese in potassium tetraoxo manganate what 7, in potassium tetraoxo manganate what? Manganate what? 7, right? That is what we say was solution, right? This is giving us our reaction, the formula to be what? Potassium tetraoxo what? Manganese, right? Potassium tetraoxo what? Manganate what? 7. So this is our formula for this. Now solving what? For oxidation number is as simple as what? A, B, and what? C. So what we are looking for is what? Manganese, right? What we are looking for is what? Manganese, and this is our what? Manganese. That is why it is very, very important you understand the oxidation number of what? Different what? Elements, right? So this we are going to say what? K plus what? You say we are going to say what? K plus what? Mn plus what? 4 times what? We are going to say what? 4 times what? O, right? Which is our oxygen equals to what? 0. Why it is 4 times O is because of this what? 4 here, right? Times this what? Oxygen, right? So we are going to say what is the oxidation number of potassium? The oxidation number of potassium is what? 1, right? Plus what? Manganese, which we are looking for, plus what? 4 times what? The oxidation number of oxygen is what? Minus what? 2, right? So we say 1 plus what? Mn plus what? 4 times what? Minus what? 2. We already know that 4 times 2 is what? 8. So we are going to say is 1 plus what? Mn plus what? 4 times minus 2 is what? Minus what? 8. So we are going to say minus 8 equals to what? 0, right? And we know fully well, we are continuing from message, plus times minus is what? Minus, right? So what we are going to say is what? Our 1 plus what? Mn, our 1 plus Mn minus what? 8, right? Our 1 plus Mn minus what? 8 equals to what? 0, right? Now what we simply have to do is what? Collect like terms what? Together, right? We are going to collect like terms what? Together. So what we are going to have here is our what? Manganese equals to what? So these are going to cross the what? Equality what? Sign. So what we are going to have here, the 8 minus 8 crosses the equality sign, it turns to what? 8, right? And plus 1 crosses the equality sign, it turns to what? Minus. So we say 8 minus what? 1. So our manganese is equals to what? 7, right? So that is just how it is. Plus what? 7, right? So the oxidation number of manganese in this reaction is what? The oxidation number of manganese in potassium tetraoxo manganese 7 is what? Plus what? 7. That is just how it is, and that is how we can be able to solve what? Oxidation what? Number. When we enter our past question series, I will be teaching you when we encounter questions, I'll be teaching you more and more and more how we can be able to what? Solve for what? Oxidation what? Number. So this is basically based on the what? Types of what? Reaction, talking about what a reaction is all about, talking about the substances that starts what? A reaction, right? So it's the substances that gives you this reaction, they are known as what? The reactants, and the end product or the end process is known as what? The product, right? So that is just how it is. We have talked about the combination reaction, we have talked about the displacement reaction, we have talked about the decomposition reaction, we have talked about the oxidation and the reduction, we have talked about the we have talked about what they call the catalytic reaction, and we have also been able to give the different characteristics of what a catalyst, and we have been able to differentiate between a catalyst and what an enzyme. So this is basically everything you're supposed to know for this topic, and like I said, for every topic taught, we are also going to solve past questions on it. And for you not to lose out, please don't forget to hit on the red subscribe button, and also share this video to your friends so that they can come here and get value. And in turn, I'll feel motivated to continue dropping videos like this. Their dream of scoring up to 300 plus in JAMB UTMA is very achievable, and this can be done when you follow each of our lecture series one after the other and put in the work when nobody is looking at you. That means you have to study, study, and study like there is no tomorrow. Your dream is very valid. And until I see you in my next video, always remember that you're wonderful, always remember that you're unique, and always remember that you're a pace setter. I really love you. Thank you.